Okay, so welcome back everyone to episode 2 of the C++ series where we are going to start talking about data types in the C++ language. Before we jump into things though, I just want to give a quick reminder that I do have those before you watch links posted down in the description below, where I'll post videos, sometimes I'll post articles and stuff like that, and basically it's just a very quick overview of maybe some of the terminology we're going to talk about in the lesson, or at least some related concepts. That way you have a gist, or a bit of a gist of an understanding of some of the terminology that will be covered in the lesson before we jump into it. And I post that mostly for beginners, so if you're an advanced developer you probably don't need to do so. So today we're going to talk about data types in C++. And why do we need data types? Well, in the real world, we can see data, we can sense data with our our physical senses. So if I walked into a store and I bought 3 apples, and I walked out of the store, you could physically see that I had 3 apples. You could count them, you could see them, you could touch them. You can see that I have indeed now have 3 apples after I purchased them from the store. Well, in programming and in code, we have to figure out a way, basically, how do we relay that information to a computer? So how, for example, if we bought 3 apples in a computer program, in a computer application, how do we basically relay that information to the computer to tell our computer now that we have bought 3 apples, that we have 3 apples? How do we represent that? Well, we do that by using something called data types. And so in programming, data types are essentially a way to represent what data means and what operations we can perform on that data. But data types can represent anything from, numbers, words, physical objects, and the functions we can perform on that data. So for example, if we had 2 data types that were numbers, we could add those together. But if we had a data type that was a number and another data type that was a word, well, we couldn't do a mathematical addition on that, because you can't add, at least not in real life, we can't add a number and a word together. So in this lesson, we're actually going to talk about a subset of data types called arithmetic types. And so we have here the entire space of data types in C++. And then within that, we have a subset of those data types called arithmetic types. And within arithmetic types, we actually have 2 different groups within there that are called, and we'll actually split this right down the middle. We have integral types, and we have floating point types. Now, floating point types essentially are any kind of decimal number, so like 1.2, 2.4, 5.687, anything that represents something that's not necessarily a whole number but has a fractional value on the end of it. So C++ splits this up into a couple different data types within the floating point group. And so we have float values. Hope you enjoy my terrible handwriting there. We have float values, we have double values. And again, just remember, these are all different kinds of data types in C++. And then we also have long doubles. I'm just going to say dub, call it good. Now we'll get to why we have different data types that all represent decimal values in a little bit. We'll talk about that in a different video. It has to do with the amount of precision that each one of those has and how much space they take up on your computer as far as memory is concerned. But for now, let's move over to integral types. And in integral types, we have multiple. Integral types are primarily representing integer values, so like whole numbers, so like 1, 2, 3, 4, 5, -1, -2, -3, any whole numbers. But we also have several different types of integers in C++ as well. So we have short values, we have integer values, which in C++ they're just called int. We have also long values, and then long. And then on the integral side of things, we also represent characters in the integral category, which C++ just calls character a char. And then we also have Boolean values, which is just a true or false value that we call bool. Now we'll be going over each one of those, so don't, if something there didn't make sense to you, don't worry about that right now, but we'll be going over each one of these in this lesson. So, but yeah, that's kind of how the arithmetic types are split up in C++. You have the integral types and you have the floating point types. And again, a floating point, you have floats, doubles, and in integral types, you have shorts, ints, longs, longs, characters, and then booleans. So the first group that we're going to talk about in this lesson are integral types. We're going to start with integral types. And before we can start talking about data types, we have to understand how we represent or how we store values for data types in C++. And to do so, we use what's called variables, and we use variable names to reference that variable. So kind of like how in mathematics, you can have something like you can set x equal to 3. And so now you know the value of x, whenever you see it somewhere, is 3. So if you had an equation like 3 plus 3 equals 6, but you could substitute one of these 3's out for x. You could do 3 plus x equals 6 because x equals 3. So basically, x here is storing the value that is 3. So same thing in programming, we can make variable names basically to store values of different data types, like a short variable or an int variable or a character variable or a long variable. And we do that basically, and what you'll see in the editor here in just a minute, but basically we do that by, for example, if we made an int, we could say int, you start with int, which is a keyword, and keywords are basically just reserved words for the our editor. They're special words for the editor that you can't use as variable names, so we couldn't use int, for example, as like an x to reference a value. So you could say int, and we'll say x equals 3. And that would store the value of 3 into x. So now we can use x anywhere in our program, essentially, whenever we want to use this value of 3. So let's go into our editor here, and let's actually see how we can write a line of code that does exactly this. So we're going to start with our data type. If we want to declare a variable of an int type, so an integer that is an int type in C++. So we would write int, just like we saw before in our little drawing mock-up here. We would write the keyword int, and again, I want to make sure, I don't know if I explained this very well before. So things like int, short, long, float, double, and there's a lot more. Those are keywords for our editor. I say they're keywords for the editor. They're actually keywords for the compiler, and we'll talk about that more in the compiler section. But they're keywords, meaning we can't use them as variable names. So we couldn't say like int equals x, or excuse me, equals 3. We couldn't say that because this word is a reserved word that the compiler needs to have as a special word to represent an integer, for example. So we also couldn't do something like short equals 3 because again, short is a data type, and the compiler needs to reserve this word to know that the variable we're making is of type short. So we can't use reserved words. The editor and the compiler physically will not let us do that. So let's bring our int back here, and we're going to write int x just like we saw before. So remember, x is actually our variable name. That's our variable name. That's the name that we're going to reference when we need to access our value. And we're going to say equals. So this equals sign is actually what we just call the equals operator in C++, or I should say it's called the assignment operator in C++. We use this when we want to assign a value to something. So in this case, we're going to assign a value of something to x. And it needs to be of type int, which is just an integer. So then we can say 3, and 3 is the value now that we are assigning to x. which is of type int. And you'll see me put the semicolon at the end. I'm sure if you come from another language, there's a lot of languages that do this, but every time you end a statement in C++, you have to put a semicolon at the end. It just basically signifies that that's the end of a particular statement of code. So that way if we went on to the next line and we declared another integer, we call this one y, equal to, we'll just say equal to 1. The compiler now knows where this statement ends, and then the next one is probably going to begin. So if we remove the semicolon, you'll see here now that we get an error because the compiler now doesn't know where the end of this statement is. It knows by the semicolon. So what other kind of data types do we have? Well, we wrote that one out just a second ago. We had a variable type short. Let's call this short variable, let's just call this var short, meaning variable a short variable, or a variable that is of type short, and we'll set this equal to 1. So you can see that this also accepts values of integer types, because these are both, at the end of the day, they're just integers, and we'll explain here in a second why C++ has different types of integers, different data types, both representing integers. We can also create a long. We'll say var long equals, so let's set this one equal to 5. So now we created a variable of type long, and we set its value equal to 5. And that's really, for the most part, that's all of the integer types. There also is a long, and that we can call, we'll just say var long, and we'll set that equal to 6 just to differentiate it from the other one. But so these are all different kinds of integer data types that we can use in C++. So the reason C++ has different data types that all represent integers, so we have shorts, ints, longs, longs, and these can all be assigned an integer value like we've already done here. And the reason being is because these data types can be, that all represent integers, can be assigned different ranges of values of integers. So for example, for shorts, make a little comment here, these can only be assigned, shorts can only be assigned values in the range negative 32,768 to 32,767. Now this will make more sense when we get to the video on binary, because we're going to look at how C++ represents these different data types under the hood in binary, and then it'll make more sense why certain data types are restricted to certain ranges. Now ints, I'm not even going to try to pronounce this number, but this is the value, the range of values for an int. You can see it's a bit larger than our range of values for short. For longs, this is the typical range of values for longs. And then finally, for longs, you can see that this is a bit more substantial than our range of values for short. And so if we copy the maximum for a short, paste that there, this would be the maximum value then that we could assign to this short. Now if we copy this row statement here, and then I'm going to paste in the minimum value here, this would be the minimum value that we could assign to a short as well. And actually we got to change this variable name. If you're, we'll talk about scope later, but basically if you're in the same scope in a program, you can't have the same variable name. That's just why we had to change that to a var short 2 instead of just var short. But anyways, if you go out of the range of values for a particular data type, and I'm just going to take the short again here for an example. So right now our maximum value for short is 32,767. Now if we were to set this to 32,768, which is 1 over the maximum, the compiler will actually wrap this value back around to the minimum value. So if we print this out, which I already have set up there, we should be expecting this minimum value here. So let's do that now. And boom, there we go. 32,767, I should say negative of that number, which is exactly what we were expecting. Now, if we were to even add one more to this, we should actually expect this now to be negative 32,767. So let's try that again. Yep, negative 32,767, exactly as we expected. And again, when I make that video on binary and how these different data types are represented in binary in C++, all of this, as far as why certain data types are restricted to certain ranges, is going to make a lot more sense. So if we go back to the drawing we made, where we were talking about arithmetic types, and we were talking about the integrals group specifically, we made a data type, or a variable of data type short, that we set equal to 1. We made x and y, which were of type int, which is we set to 3 and 1 respectively. We created a variable of type long that we set to 5, and a variable of type long that we set to 6. Now there's these two others here that we haven't talked about yet. Char stands for character, basically. And basically it's exactly what it sounds like. It represents a single character, so it's a single character usually from your keyboard. So the letter Q, the letter S, the letter D, letter G, any of the numbers, parenthesis, asterisk, percentage sign, it can be any character from your keyboard. And it represents a single character. Boolean, on the other hand, only has two values ever. It's either true or false. It's a true or false value. This is used a lot of times when we need to check conditions, which we'll talk about later on when we get to if statements. But for right now, just know that this is always going to be either true or false. So if we go back to the editor here, and we create a variable of type char, and we'll just call it varchar, and we'll set that equal to a character. Now, when you create a character, and in C++ it's called a character literal, you have to type two single quotes. You surround the character with two single quotes, so we'll just put an A in here. So we've created a variable of type char that has the value of the character A, character literal A. Now you notice that we hover over this, we see that the hint here tells us that this is of type char. This isn't super important right now. I don't want to stray too far from the topic of this video, which is talking about the basic arithmetic types. But if we type a second character, what happens is this actually becomes what's called a multi-character literal. And so if we hover back over this now, you'll see that this is turned to a type of int. So the C++ standard says that a character type must be a single character. If you type two characters for a character type, what happens is the behavior of this assignment here, the behavior of this assignment is then turned over to the compiler to decide what to do with it. Since the C++ standard doesn't specify what to do if you have a character literal that's more than one character, which again is technically called a multi-character literal. So since we're using Visual Studio has its own compiler called the Visual C++ compiler, and so basically the language specification hands over the decision of what to do with this multi-character literal to that compiler, and it has decided through its own implementation that it is going to turn any character type that has more than one character within the single quotes, it's going to turn that to a type of int. So basically an integer type. The way in which it does that, we're not gonna talk about that right now because I don't want to get too into detail and all of that. We'll hopefully bring that back up later on when we talk about some of the odds and ends of C++. But just know for right now that is the behavior that will take place. And so whenever you create a character, always keep it as a single character, just one character when you create a data type of type char. Now, if that didn't confuse you enough, let's talk about the Boolean type now. So when you create a Boolean type, you just type bool. So this is a type of Boolean, and then we can just say bar bool. And we can set this either to true, which is literally going to represent a value of true, or we set it to false. And again, this just literally represents a true or false value. And so oftentimes we'll use Booleans to check certain conditions. So when we get to the section on if statements, you'll see that put into practice. But we can do something with this, like this, with booleans. I'm going to use an operator here that you haven't seen before, so don't panic. Well, this is an arithmetic operator that we're going to talk about. We're going to learn in an episode down the line. But I'm going to make a boolean value with a variable name called is y greater than x. So, oh, let's spell that there. So is y greater than x, and we're going to set this equal to this statement. So again, you haven't seen this operator before, so don't panic. Don't, you know, I know we haven't talked about this yet, but I just want to show you what kind of what these Boolean values can do. So basically what this statement right here is going to do, where we have y greater than x, it's going to check if y, our y variable, is greater than x. Its value is greater than x, and we can see clearly because we hard coded it. We can see what the values are. We know this statement is not true. It's false. So this should come out as false. Well, we're actually going to print it out to the console here, like we did in the previous video with our hello world string here. So we're going to go ahead and get rid of this. In its place, we're just going to put is y greater than x. Now, when you print a Boolean to console, it kind of converts it to a string, and as a string or as an integer, Booleans are either 1 or 0. It's a 0 if the value is false. So if a Boolean value is false, it's actually 0, and if a Boolean value is true, if a Boolean value is set to true, it would actually be 1. So it's either 0 or 1. So we should see this print out as 0 since we know this statement is false. So if we run it, you can see here that we get a 0. Now if we flip the tables here and we said y less than x, and instead of this we say is y less than x, and we're going to have to replace our variable here in the print statement, console, go ahead and click run. Should be a 1 now. Looks like nothing printed. There we go. I had to click my enter button for some reason, but you can see now that we have a 1, which means it's true, which makes sense because y, we can see here clearly that y is less than x. So I know we did I talked about some weird stuff with, you know, converting a Boolean to a string there, some extra things that we didn't talk about. We'll actually have, actually one of the next couple lessons here is going to be about converting, how you can convert one data type to another and how C++ does that in some cases automatically. So we'll be talking about that too. And I feel like I am saying a lot that we're going to be talking about stuff later, and it's true. It's just because we can't cram everything into one video. There's just a lot that builds on itself in programming. And if we try to cram it all into one video, if I tried to stray off and talk about a related topic, I mean, this video could be several hours long. So I don't want you to think that we're going to say we're going to get to it and we'll never come to it. We will talk about everything in detail that we don't cover in each lesson. So with that being said, I was actually going to cover floating point types in this video as well, but this video is starting to get a bit lengthy, so I am actually just going to call it there. We've talked about basically what character types are, what Boolean types are now, and so we basically covered integral types for the most part. There's a little bit more to it. We're going to get to some of the odds and ends stuff because characters, actually, there's multiple different types of characters you can make in C++ that you can define. And we'll talk about those and what they're used for. But as far as the basic integral types go in the arithmetic types for all the data types in C++, we've covered them for the most part here. So I'm going to wrap it up there, and I will see you in the next video where we're briefly going to cover floating point types.